Now we are going to check out the other type of supervised learning, that is regression. In regression tasks, the target variable typically has a continuous variable, continuous values such as country's GDP or the price of house. Yeah, those things. So in order to work on this regression, so I will use the one data set. So first to work on this data set, I need to import the first this pandas. Then I'm importing the my that data set. I'm printing the first five of head. If you see these are the features, and in the features there is the target variable also there. Here, to conceptualize the regression problem, let's use a data set uh, containing women's health data to predict the blood glucose level. We load the data set as a pandas data frame and print the first five levels of first five rows. It contains the features including the pregnancies and triceps skin fold measurements, insulin level, body mass index known as the BMI. Here BMI is there, age in years, and diabetes status. With one indicating in the diabetes status, one indicating they are taking the diagnosis, a zero representing their options of the diagnosis. That is diabetes column. And to create that, to recall the Scikit-Learn requires a features and target values. So here we need a features and target values to is in distinct values x and y to use all of the feature in our data set. We drop the target from the data set, that is a blood. Here the target value glucose, that is blood glucose level, and show the values attribute and x mean as x for y. We take the target column value attribute. We can print the type of x and y to confirm they are now both numpy errors. So what I'm doing here is programmatically what I will do here. Programmatically what I will do, I will check the shape of this. This is the shape of this. This is there is 178 rows are there, 9 features are there. From this, what I told, now we will take the data set where all the here the glucose levels not equal to 0, BMI not equal to 0. That we are removing the zeros. Basically, BMI 0 and diabetic glucose levels are 0. So now again we will see the data shape. So here the shape SHAP shape equal to 752 and 9. So there is nearly 8, I think, 8 or 10, nearly 14, I think 14 are removed. Zero sub values are there here, and then that the shape. What is the? I'll check the. I'll see what is the total from the 768 minus 752 total. 16. Yeah, I told the 16. 16. I mean 16 rows are removed because there is a 0, and for the both glucose and BMI that 0 is there because we are using AND operator here. So that is shape of that new data frame. From this, what I will do, I will drop the glucose from this data set. That is called, we are taking as a feature. There X is a feature where we are removed the glucose. So then remaining whatever the things are there, that is we are taking as the features. Then where is the glucose is taking, we are taking it as a Y. So now we got the X and Y. X is nothing but all the feature, Y is nothing but target variable. So if you print this two, so how the things, so the data type, what is the data type here? Both are numpy. So next, if I'm printing the first five rows of this, so first row is 6, 72, then if you see, there is no BMI 30, 148. There is no 148 because we removed the 148 from this thing and removed 148. First row, that's what glucose is 148, right? And first row is 148, 85, 183. These values are not there in this after pregnancies. After pregnancies, 148 is not there. Directly 72 is there. 72 is there. So because from the X we removed the glucose. Then I want to print the that is the what you call x1. So suppose I want to here, what I will do, the main thing I will take is the BMI as my from this BMI, from these values I will take a BMI as my x value. First I will take the x value. So we will do what we will do, we will take the x value as BMI, y as this glucose, then we will predict that. So I will take the print the first 5 values of BMI. This is the first 5 of the BMI. So 5 values of BMI. Say what is that? 30, 33, 26, 23. These values are BMI values. And then if you see the shapes of that both x and y, if you see both x and y shapes, so both are 72, but here we need to convert this value into x BMI value into one dimensional array. So what I have to do that, we need to use the reshape that. So we need to do the reshape. So again you can print the shape now. So now it is the 172 1. This is the BMI shape now. We converted to, yeah. So what we did here, we converted that to one dimensional. So everything is good now. Here basically say that both one dimensional arrays, both are one dimensional arrays here, both are one dimensional arrays. Then what we'll do, we'll directly we can plot this, how the relation between a BMI and what you call glucose levels. Then I will copy this type of the code here. Just I will copy the code. See this, the code. So body mass index and glucose is both are incremental. In both are in a increment. It is incrementing. Here we see that x-axis and y-axis labels also, and as body mass index increases, blood glucose levels also intend to increase here. Now what we will do, we will fit the model. How to fit that? First we will take the regression model. I will talk about the linear regression in the coming classes, but take now this particular, we plot this particular linear regression. We will fit the XBMI and this thing. Now we fit it. So then we will see the regression line. So to do that, this is the code to please see this. This is the regression. We fit that. So then that is we are fitting that. So first what we did, it's to fit the regression line in our data. We are going to model regression. We use the linear regression model, which fits the straight line to our data. We will explain the later. I will explain the about the linear regression in detail in the coming videos, as we model the relationship between the feature and body mass index, targets blood pressure. Yes, we use the now the both. I mean, it's an incremental level. That is the linear regression. Okay. We produce this scatter plot again, and that is this thing. Then the black line represents the linear regression model fit of a blood glucose values against the body mass index, which appears to the weak to moderate positive correlation. That is, this is one example. Regarding this is diabetes of a woman health. So we did the body mass index and glucose level. There is a positive line is there in between. The relation is positive. So another example I'm taking, that is what you call sales. How the sales? If you see this, I will show you the. Again, I'm importing one data set, that is sales data set. If you see the sales data set. If you see that the sales data set, so first so there is the TV, radio, social media, influencer sales. So they're taking, I mean, they are taking all these things, how the sales are going, where they need to improve the I mean their to improve the sales, where they need to focus, whether the TV advertising or radio advertising, social media, and all the things they need to consider. So in order to do that, which is the what is the, I mean, first of all, how the relation between the radio and the sales, we will see that first. I'm taking as a radio as a my radio as a my X value, how the relation X value, and y is my sales is my y value. So I'm reshaping this X value. Now, if you see the print print x type type x comma typ type y. So both are numpy arrays. So if you see the shape of that particular shape, there is 140 4546, that is x, and these two are now both are one dimensional arrays. Now I will import the sklearn. Already in a feature and a previous example I used the linear regression. Same thing I'm using here. I'm creating the one object for the, that is reg, and I'm fitting rig.fit. I'm passing the x and y. Now I will do the prediction on the x. I'm predicting. Then I'm see the first five values. This is the predicted values. So first five values are the predicted value. So show once you plot this thing, how the regression line. Sorry. Once you plot this, how the regression line will be. I want to plot this one. This is the plot. This is the regression line. Again, this is the positive relation is there, sales and radio expenditures. So that is the this thing relation between the radio and this is the positive. This is the red line indicates that there is the positive relation between the sales and radio expenditures. Yeah, we will connect in next video. Thank you.